Hello, in this video we're going to have a look at linear equations. Specifically, we're just going to be looking at modeling linear equations based upon some information given to us in the problem. So let's get stuck straight into it. A linear equation is, I guess the formal way of describing it is it's an equation where the highest power of the variable in the equation is 1. So this is an example of a linear equation because t is raised to the power of 1, same as here. This is an example of where a linear equation is not linear because it's t squared. This one here, change your variable, but also it's not a linear equation because if I expanded this, x times x would give me x squared. So just be mindful of that. It's if you can rewrite it so that it's got a squared term or higher, then it's not a linear equation. Similarly with this one here, although the x has a power of 1, it is on the denominator. So you might remember from your index laws work that in fact if you have a variable or a number on the bottom that's actually raised to a negative power, so that's actually x to the power of -1. So this is also not an example of a linear equation, but the top two are. So let's go have a look at a couple of examples. I'm just going to demonstrate the whole modeling of the problem. So we're on slide 7 now. So this is from the textbook, exercise 1B, question 3. The sum of two numbers is 42. One number is twice the other. Find the two numbers. You don't have to formally set it up like I'm about to, but I tend to do that because it helps make my thinking be clear. And note that I've highlighted some of the key words just so to remind myself. I probably should have highlighted the 42 as well, possibly. So with the right things highlighted, we've just got to use a variable to describe something that we don't know and then go from there. So something like this. Let one number be x. I could have used n or anything really. Then the other number is twice that, so 2x. So it's really important that you have some statements declaring what you're about to try and figure out. Let's use the other fact, which is that the sum of the two numbers is 42. You're in trouble if you don't know that sum means the result from adding, but that's what it does mean. So I know that I've got x, therefore x plus 2x is equal to 42. And now I'll simplify the left-hand side to 3x is equal to 42. And I'll divide both sides by 3 to get x is equal to 14. Now, do note that it's important that you answer the question. It wasn't find x, it was find two numbers. So you can respond, excuse me for squishing it in, i.e. the two numbers are 14 and 28. Now, although you might not be marked down for communication in an exam, because we don't mark communication in the exams, it is nevertheless a really important thing for you to do. It takes not that long to write that down, and it crystallizes your thinking, and it reminds you, have you answered the question? Okay, let's have a look at example 2, which is an interesting one. It's also from exercise 1B, question 7. And it's find 4 consecutive odd numbers. So there's some key words there that if you don't know the meaning of them, it makes it difficult. Consecutive, you should know what an odd number is. And again, there's that sum, again, the sum with a sum of 80. So consecutive means one after another. So 1, 2, 3, 4, 5, or 12, 13, 14, 15 are consecutive whole numbers. Consecutive even numbers would be 6, 8, 10, 12, and odd numbers would be 1, 3, 5, 7, etc. Now, the trick with these ones, it is a trick, so it's worth just paying attention to this, is we start off, how do we describe an even number and odd number? So really quickly, I'll go through this. So if we say let n be any whole number, fancy word for that is integer. You probably know it already. Then 2n are all even numbers. Think about it. If n is 0, we would get 0. If n was 1, 2 times 1 is 2. If n was 2, 2 twos are 4, etc. And then how do we go from even to odd? Then Well, an odd number is one more than any even number. So you've got 2n plus 1 are all odd numbers. Okay, now you wouldn't normally put all that writing down. I've done it just to help construct it a little bit. But basically, you need to know that 2n will generate a set of even numbers and 2n plus 1 generates a set of odd numbers. So what about the consecutive nature of it then? So we have 2n plus 1 as one of our odd numbers. Now, if that's the first one, what's the next odd number going to be? Well, it's going to be two numbers are over. So we're going to have to add 2 to 2n plus 1. And so we get 2n plus 3. And then we get 2n plus 5. And we get 2n plus 7. They're our four consecutive numbers. And they have to sum to 80. So I'm going to do this sort of just verbally, and hopefully you'll be okay with that. So the first thing I'm going to do is going to collect the variables together. So I've got 2, 4, 6, 8. So we've got 8n plus 1 and 3 is 4, 4 and 5 is 9, 9 and 7 is 16. So we've got 8n plus 16 is equal to 80. 8n is equal to 64 by subtracting 16 from both sides. And then if I divide both sides by 8, I get n is equal to 8. 64 divided by 8. Again, a bit squishy, but I'm going to go over here. Remember to answer the question. It didn't say to find out what n is. N's basically just our starting number. Okay? Well, not our starting number, but our starting position. It's the 8th odd number along. So we substitute 8 into n here and work out what our first odd number is going to be. 2 times 8 is 16, plus 1 is 17. So therefore, the numbers are 17 is the first one, and then we can just list the other ones: 17, 19, 21, 23. And you can go back and substitute in to make sure that makes sense. We've got n equals 8, n equals 9, n equals 10, n equals 11 there. Will give us what we're looking for. And we're basically done. So if you go to exercise 1B now and have a go at the questions that were listed in Google Classroom, then you should be able to model them yourself and then solve the problems.